Hey guys, I'm going to go over this review for you guys. Oopsie daisy, this is not labeled correctly. There we go, much better. Get the right pins here. Alright, so this review is going to be a little bit out of order. Not my fault, the CIA did it. So, match it up according to the worksheet I posted. But I do believe I got all the problems on here, okay? So, we'll start with this bad boy because he looks pretty difficult and these look easy. So remember, you need to cross multiply. Okay, 1 times 5x is going to be 1 times 5x. Okay, and then this is 2 times 3x plus 2. So that's 2 times 3x plus 2. Okay, don't forget the parentheses because you're going to need to distribute. Okay, but first of all, 5 times x is 1. 5x times 1 is 5x. 2 times 3 is 6x. 2 times 2 is 4. Boom. Let me fix this. Alright. So, x is on one side. Let's just go ahead and subtract this 6x. And we get negative 1x equals 4. Divide by the negative 1. And we get negative 4. That's right. Boom. Easy. Biggest headache here is the distributing part. Please don't forget to do that. So many students will just multiply by the first term, forget all about the second one, and get the wrong answer. These are a little easier. You just cross multiply. So that's 10x. 7.5 times 4. I don't have my calculator. Where's the Desmos thing? I don't want to say it's one thing, it'd be something else. I'm going to pause the video. Let me get my Desmos. Alright, so got my Desmos calculator up and running. So 7.5 times 4 is going to be shirty. And divide by 10. So 30 is going to be 3x. Easy peasy. Over here, cross multiply again. I like to put little arrows on there. But we're going to have 21 times x. 7 times 3 is 21. Divide by 21. And we get x equals 1. Easy peasy. Boop. If we have triangle ABC is similar to triangle DEF, solve for x. Okay, show your work. If triangle ABC is the pre-image, the scale factor is. All right, let's solve for x first. We got CB. Let's put x first when we do our proportions, and then go from there. CB is the last two. EF is the last two. 3.5. Safe to assume 3.5 and x are correlating to each other. And then we need some other number values. See, I can't do AB. There's no number over here. We can do CA because CA correlates to DF, so 2 over 1. I need to put 2 over 1 because x is from the bigger triangle. So the bigger triangle numbers stay on top, lower or smaller triangle numbers stay on the bottom. Same step, you can just cross multiply. We get 1x. 2 times 3.5 is going to be 7. You really don't need the 1 there, but it kicks and grins. You can divide by 1 and you get 7 equals x. That's what they're asking for. So we got 7 here. Now, we need to find the scale factor. We can use the ratio between 2 and 1. 2 and 1. The issue here is ABC is a big triangle and it's getting smaller. So it ain't 2 over 1. That means it's getting bigger because it's greater than 1. We need to do the reciprocal of 2 over 1. Flip it. We get 1 over 2. 1 over 2 is less than 1. So that means it's getting smaller. And that fits the situation. So we should have 1/2. Okay. So it was like a two-part question there. Number 2, same thing as before. We're looking for the scale factor and we're trying to find for x. ABC DEF, so it's pretty much like it looks. So start with X, setting up proportions. X corresponds to, we got DF, AC, so 4. And then this is missing a size, so we got EF, so that's 7.5. That should be over 5. So you BC, EF, same thing. So 5. You can cross multiply. Let's see, remember that was 30 a second ago. So 5x, because we're multiplying. Divide by 5. You get 6 equals x. Again, thinking about ratios. We just solved for that bad boy. So look, one of our ratios is 6 over 4. That reduces to 3 over 2. But is this okay? It's greater than 1, so it's increasing. Our preimage is ABC, so it's getting bigger. Okay, 3 over 2 is greater than 1, so it is going to get bigger. So 3 over 2 is our right answer. If it was getting smaller, we would need to flip it to 2/3, but that's not the situation right now. Boop. Look at the sunshine. So, on a sunny day, an office building casts a shadow that is 80 feet long. At the same time, a 5-foot person casts a 6-foot shadow. Determine the height h of the office building to the nearest foot. Show your work. Guys, you got 2 triangles. You got this little triangle, and you got a big triangle. Okay? So, big triangle is going to look like this. H with the 80. Little baby triangle is going to look like this. 5 and 6. And it's practically set up to a good proportion. H over 80, 5 over 6. And this is okay. So cross multiply, get 6H. Oof, 5 over 80. Pretty sure that's 400. But when in doubt, grab your calculator. 5 times 80. Yikes, that's... I gotta clear it. Try that again. 5 times 80. 400. Like I said. Divide by 6. They want it to the nearest foot, so let's not forget that. Boop. So 400 divided by 8. We get 50. No, not 8. Not 8. What am I doing? 6. There it is. I was about to say. So 66.66666 repeating, obviously. Round to the nearest foot. The 6 rounds that 6 up to a 7. So 67 feet. Boom. Done. We got 2 pentagons here. ABCD, ABCD, EF, or excuse me, FG, HG. So it's like they look. I was checking with the order up here. Okay, so find X. So again, set up the same thing. So X is up here, ED. So that'd be corresponding to 3 ED last, JK last 3. Yeah, good. And let's do 3 and 2. GH is in the middle, BC is in the middle. So yeah, so X is with 3, so we're going to put 3 on top and then 2 on the bottom. Don't forget these 3's are 2 different 3's. Okay? That 3 came from right here. This 3 came from down here. Okay? The bigger pentagon numbers are on top. The smaller pentagon numbers are on the bottom. I'll put this in red. Leave the arrows there so you can see. No, I'm going to delete the arrows. We don't need the arrows anymore. Excuse me. Get rid of those. Get back my blue. People be texting me. It's not like I'm trying to make a lesson here. 3 times 3 is 9. Then we have 2x. 2 times x is 2x. Divided by 2. And we get 4.5. Okay. Scale factor. Again, we can just focus on that 3 over 2. The ABCD is the preimage. It's getting smaller. So we need to flip this fraction so it's less than 1. So 2 over 3. So 2/3. Again, greater than 1 it grows. Smaller than 1 it shrinks. Boop. If the square Hij to the right is dilated by a scale factor of 1/3, with the center of dilation at 0, 0, that's right there. I'll change colors. Right there. With a center of dilation of 0, what will be the coordinates for K prime? Guys, we are not redrawing this whole image. All we care is where K prime is going to go. 1/3 dilations in the center, so that means we just have to multiply that point. That point is 3, -3. All we need to do is multiply that by 1/3. All those numbers get multiplied by 1/3. 3 times 1/3 is 1. -3 times 1/3 is -1. This is our K prime. This is all they care about. K prime. That's it. Boop. Take a quick glance at my phone here. The quiz isn't working. Yada, yada, yada. Oh, jeez. I will reply to these later. So, given the pre-image ABC to the right, calculate the coordinates A prime, B prime, C prime if the dilation has its center at the origin. And the scale factor is 3. Origin's right there. So, A coordinate is going to be -4, 0. So I'm going to put that right here for safekeeping. Oh man, this heading is too much. I gotta fix that too. Bump it down a little bit. Save that. Alright. So -4, 0. And I'm putting it up here because that's A. This is B. So your B's at 2, 3. And then C is at 2, 0. All right. We just have to multiply by 3 to everything. So 3 times -4 is -12. And then obviously this is 0. 3 times 2 is 6. 3 times 3 is 9. 3 times 2 is 6. 3 times 0 is 0. That's all we had to do. Didn't say anything about drawing it. Okay. And when the center dilation is at the origin, or 0, 0, you just need to multiply. Same thing, given the pre-image ABC to the right, draw an image for a 1/3 scale dilation, and the center dilation is at 2, 0. So I'm going to erase that origin point and then remind myself we're at 2, 0 right there. From here, you have to count. I feel like counting is the easiest thing. 1, 2, 3. Then you multiply that by the 1/3 for the scale factor for this new problem, and you get 1. We'll deal with that in a second. Down here, 1, 2, 3, 4, 5, 6. Multiply that by 1/3, and we get 2. I'm going to change colors real quick. So from that point, go up 1. From here, go over 2. And this third side will take care of itself when you connect the dots. Boom. There's your new image of the triangle with the 1/3 dilation. And it makes sense. 1/3 is less than 1, so it did shrink. And if you remember, since these two sides go through the point, they stay put. But this side did not go through the point, and it moved. And remember, those lines are parallel to each other. Boop. Given the pre-image triangle DEF to the right, draw an image of the dilation with the scale factor of 2 with center dilation at 0, 0. So again, all we have to do is multiply by 2. Put 2 on these little arrows real quick. So -3 times 2 is -6. -2 times -1 is -2. 2 times 3 is 6. 2 times -1 is -2. 2 times 3 is 6, and 2 times 2 is 4. Alright, something's not right here. -6, 6, 6, 2, 3, 4. Okay, never mind. Never mind. Well, you know what? We'll plot it, and if it doesn't look right, we'll find out real quick. So, -6, -2, This is going to be our D prime. Then we get a 6, -2. That's our E prime. So far looking pretty good. E is 6, 4. That's right up here. That's still in alignment with that side. So I think all in all is pretty good. Trace it. Obviously I could have used a line tool, but you know, time is precious. There you go. And take notice, again, every line is parallel to its original. Okay? Because none of them went through the center dilation, so that makes perfect sense. Boop. If measure of angle A equals measure of angle D and measure angle B equals measure angle E, could you be sure that the triangles to the right are similar? If so, which triangle, postulate, or theorem could you use? Again, I would mark these triangles. This is congruent to D, B is congruent to I, and immediately you already see what postulate we're using. Angle, angle. Well, I guess I should have answered the question. Yes, they're similar because of angle, angle. Man, y'all are just blowing my phone up, and you know who you are right now, because I'm going to put a little time down there. See, 12:02. You're blowing my phone up. Again, same question. Essentially mark what's, similar, congruent, etc., etc. So A and D again, boop, bam. I like to do this with these proportional sides. AC, squiggly worm, is proportional to DF. I did not put a tick mark because these are not congruent triangles. I mean, just look at them. There's no way they're congruent. The angles could be congruent, but not the sides. So I use a squiggly worm. Squiggly worm for CB. Don't even know if this is correct math. I felt like I've seen it before in a book somewhere, but whatevs. But if you go around, you have angle, side, side. Angle, side, side. That spells the bad word. I'm not going to say it. And so no, not similar, because we spelt the bad word. Boop. Again, mark what's given. So AB, squiggly worm. DE, squiggly worm. AC, 2 squiggly worms. DF, 2 squiggly worms. Again, I'm getting them right here. Mark congruency, we have D. As you can see, it's being sandwiched. This is one of our postulates that we can be using. So SAS. Remember, SAS is used in congruency too, so don't confuse the two in this situation. But yes, these triangles are similar. Boop. Again, more squiggly worms. So AB, DE, AC, excuse me, DF, CB, and FA. There we go. And as you can see, if you go around, you go side, 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 side. So yes, they are similar. Boop. And he has 2 rectangular gardens. His smaller garden is 8 feet long and 4 feet wide. The larger garden is 12 feet long and 6 feet wide. Which statement correctly describes Angie's gardens? The gardens are congruent. No. No, 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 no. They're literally different sizes. The gardens are similar and congruent. That's wacky nonsense. Gardens are congruent but not similar. We just said they're not congruent. Oh, more wacky nonsense. The gardens are similar, okay, but not congruent. Makes perfect sense. Must be de. Boop. Guys, when you label polygons, I think I said this before, you need to go counterclockwise or clockwise. I said that wrong. Clockwise or counterclockwise, but you can't go hopping around with these letters. Okay, once you start, you stick with it. For example, Pentagon, J, K, L, M, N, is similar to S, T, U, V, W. That W is for that one. So if NJ is 4, NJ, put it there, 4. WS is tree, put a tree. JK is 5, just kidding, haha, joke, anyone? High 5, seen better days, let me help them out. Thinking about what I want to make for lunch. I don't know. Quesadillas, maybe. X. So we just these pentagons. Excuse me, I was going to say polygons, but that's what they are. Pentagons are similar, so I do know that we can put 4 over tree because they're the same corresponding sides, and 5 over x. Okay, normally start off with x, but you know, whatever. We should still get the same answer. It doesn't matter. 5 times tree is 15. 4x divided by 4. A little wacky. Let's get our Desmos. 15 divided by 4. Oh my good grannies. Let me just clear all this out. No, that's... Okay, 4. There we go. 3.75. Or 15 over 4. We'll just see what 3.75. Pretty good. And in the quiz, trust me, I will be clear as if I want decimals or fractions, so pay attention. Boop. They want to find Ln. That's right here. Skadoosh. Let's see, we got EG, Ln. Okay, good. So those match. I can put x over 7. And then we're going to have to use 2 because there's no number right here. So Mn does correspond with FG. Again, look, see, I'm checking the order here. So, you know, don't want to be jumping the gun here. Cross multiply. 2 times 7 is 14. 4 times x is 4x. Divide by 4. I do know that reduces to 7 over 2. So, but we need a decimal. So that's one decimal. 7, 2. We get 3.5. I should have known that. What was I thinking? It's going to be our x, which is our distance between L and N. The x counted for both of those. Boop. Andy is building a model train. Model train. Let's see. Iron skirt in the front. Train. There's a train. I guess it's a train. Little thing spinning around. Smokestack. Man, that is a bombing train. The real train has a wheel diameter of 5 feet. Wheel diameter. And a length of 25 feet. Holy moly. 25 feet. The model train is a length of 10 inches. And what is the wheel diameter? So we're looking for the wheel diameter. Give your answer as a fraction in simplest form. As a fraction, simplest form with units. Tiny train. So we're looking for this little baby wheel. I'll put a little X right there. And the whole length of this train is 10 inches. Fun fact, these units do not matter because they work themselves out in the end. So we can still stack this accordingly. We can say 5 over 25 for this instance. And x over 10. Okay, wheel diameters on top, lengths on the bottom. Cross multiply. And we get 25x. 5 times 10 is 50. Divide by 25. And we get x equals 2. In this case, inches. Skadoosh, because it's the model. Boop. What does it mean for two figures to be similar? Weird. It's like I told you 4 words that would give you this answer. Same shape, different size. Same size, same shape. That's congruency. Different size, different shapes. That's wacky nonsense. Same size, but different shapes. That makes no sense. Same shape, but are different sizes. Yes. Boop. If BE is proportional to DE, so squiggly worm, AE, squiggly worm, is proportional to CE, squiggly worm. Are these triangles similar? And what postulate tells us this? Don't forget about vertical angles. Skadoosh, skadoosh. And again, it's spelling it out for you. Side, angle, side. Side, angle, side. We're using SAS. I'm sorry I'm going really fast. I'm just trying to beat the timer because we're getting closer to 30 minutes and I don't want this to be that long. Are the triangles similar? I forgot to say yes. You are given two triangles and the information that the three pairs of corresponding angles are congruent. What other information do you need to have to conclude that the triangles are similar? Two triangles similar. Three pairs of corresponding angles are congruent. Right there's your hint. We don't need any more information because we can argue angle-angle postulate for similar triangles. So, A, no additional information is needed. We have plenty with the angles. Boop. If triangle ABC to the left is similar to DEF, okay. We got angle A being 50. And we got angle E down here is 70. What is C? I'll put a little X. So, B and E should be the same because they're both in the middle. So this 70 could be transplanted over here. And every triangle should add up to 180. So 180, 70 and 50 is 120. So we'll subtract that. And we get 60. 60 should be the X. Skadoosh. Easy peasy. Boop. If triangle ABC to the right is dilated by a scale factor of 2 with the center dilation at the origin, what will be the coordinates for points A, B, C? And then they say draw it. So let's get our coordinates. A is 0, 0. Since the center dilation is at the origin, we're just multiplying by 2. And, well, 0 times 2 is 0. 0 times 2 is 0. No big difference there. Then we have 1, 2, 3. So that's 0 tree for B. So times that by, that's still 0, and 2 and 3 is 6. And then C is going to be 0. Alright, times 2, and we have 4, 0. Wonderful. Plot your points, because now they want you to draw it. Here's A prime. And B prime is going to be way up here to 6. And then C prime is 4, 0. Again, if you had a ruler, we can make this look pretty. I think this is pretty enough. Again, worried about time here. Boom, done. Notice it got larger because our scale factor is greater than 1. Boop. A rectangle has a dimension 7 by 12. Which of the dimensions below describe a rectangular that is similar to this rectangle? Similar. Let's see, we got 14. Look, 14 times 7 times 2 is 14, but 2 times 12, same scale factor, is 24, so that can't be it. 3 times 7 is 21. 3 times 12 is 36. That's a good very possibility. This one shot up by 4. This is still the 3. That ain't happening. No way that is going to work. C is our best option. Boop. Oh, we're done. Yay. Oh, and I did it under 30 minutes. Get on my level. Alright, y'all tell me how this video and audio was so I can make changes. Alright, see ya.